Здравствуйте.
D204, у меня сейчас здесь онлайн-семинар.
Понятно. Сейчас я проверю. Давай посмотрю. Это D204.
Угу.
Сегодня... Да, извините, не туда.
Okay, guys, let's open your task for class 4. Today we'll speak about game theory. It's our first class about this topic. We'll start discussing games. What is game? The metrics of game, how to solve the game, how to find Nash equilibrium, pure and mixed Nash equilibrium. We will discuss dominated strategies, strictly dominated and weakly dominated strategies. So let's see what we'll do. In our first class, the first problem. What we see, we have 3 firms in the market. The market demand for the quantity sold in the market is market demand easy. This is inverse demand function, you know it. Capital Q is for quantity that is produced by all firms. That is quantity of the first firm plus quantity of the second firm plus quantity of the third firm. I think that it is clear. Each firm has 4 units of good with no costs. No costs. And what they will do? They simultaneously decide how much to sell. So they simultaneously choose quantity that they will produce. Let's write down. Simultaneously decide how much to sell. And here are options that each firm can choose. To sell 2 units of good, 3 units of good, or 4 units of good. These are their actions, their strategies. You know it from the lecture. Their strategies. So, and our first task is to write down the strategic form of the game. Strategic form game. What is it? What is the game? The game what definition of the game contains? It contains participants of the game. What we have? Our players. We have 3 firms, so we have to write down it. So we have players. First, second, third. Then, what we should write down? We should write down their actions or strategies. Each firm has 3 actions. What to do? Actions of each player is to choose 2 units, 3 units, or 4 units to sell. And then, when 3 players simultaneously decide how much to sell, what they will get? They will have payoffs, and each firm's payoff is her profit. Yes. So their payoffs are their profits. Let's write down the profit of each firm, which depends on quantity. What we do, what is profit? It is revenue minus costs. We know that there are no costs for each firm, so we will have only revenue. What is revenue? It's price multiplied by quantity, you know it. But our firms are not perfectly competitive, so the price for them is not constant. What is the price for them? It is inverse demand function, the maximum willingness to pay, yes? So it will be inverse demand, which depends on total quantity, multiplied by the quantity that is produced by our firm. That's all. So it will be 12 minus Q1 minus Q2 minus Q3 multiplied by quantity of this firm, of firm E. Is it clear, guys? Okay?
Yep.
So this is strategic form of the game. We wrote down the game. So, and now we should write down, we should draw and write down the metrics of the game. What is the metrics? You know from the lecture. On vertical line, on the horizontal line, there are two players, player one, player two. Here are their strategies, and in the matrix, there are payoffs of two players. But what's the problem for us? We have not two players, but three players. So how to draw the matrix for three players, not two players?
Just a matrix for
if
three.
We will have two players.
Three to three, like?
No. If we have two players, we will write the strategies. Strategy for first player, strategy for second player, and there are 2, 3, 4. There are options, actions, 2, 3, 4. And here will be their payoffs if they will decide simultaneously which strategy to choose. Okay, but we have three players where I will draw the actions of the third player. It will be not 2D, yes, not two-dimensional, but three-dimensional. But we can draw like a cube, yes? So what we will do? We will draw three metrics. Three metrics, and the third player will choose in which matrix he wants to play. And that's all. I will show you. Let's begin. So we need how many metrics we need? We need three metrics because our third player has three options also. Yes. So if third player wants to play, guys, please turn off your microphones. It's disturbing. So, if third player will choose to sell 2 units, so we will have first player and second player quantities, and they will also choose 2, 3, or 4, and here also 2, 3, or 4. Then, if third player will choose 3, same matrix. 1, 2, 2, 3, 4. Two, 3, 4. And if third player will choose 4. First will also choose 2, 3, 4, and second also. Two, 3, 4. 2, 3, 4. So, okay. What we should draw in these squares, in these places? We should write down payoffs. Payoffs are profits in different situations. So I will show you 2 examples, and then we will write down very fast. So, for example, I want to write down profits, payoffs of all 3 players if the first player plays 2, second plays 2, third plays 2. So here, what it will give? If first plays 2, second plays 2, third choose 2 units. Profit of each firm will be put
12.
this 2, 2, 2 into our profit.
12 for the
12
first one.
minus, yeah, 12 minus 2 minus 2 minus 2 multiplied by the quantity. Quantity of each is the same, 2. So it will be 12. So we write down 3 profits. Profit of the first player on the first place, 12. Of the second player, 12. Of the third player, 12. And we should write down in all these squares, all profits in different situations. For example, let's choose different quantities. For example, first player will play 3, second player will play 4, third player will play 2. So profit of the first player will be 12 minus 3 minus 4 minus 2 multiplied by the quantity of the first player, 3. It is 9, 3 is 3 multiplied by 3, 9. Of the second player, price is the same as it is market demand, 3 multiplied by the quantity of the second player, 4. It's 12. And third player, 3 multiplied by 2, 6. Okay, and we should write down these profits. So, quantity of the third player is 2, so it is first matrix. Then, quantity of the first player is 3, and quantity of the second player is 4. It's here. Yes? So, let's write. Profit of the first player, 9. Of the second, 12. Of the third, 6. So guys, is it clear how to write down all payoffs in all these squares?
Yes.
So let's do it very fast. So here, 10, 15, 10. Not waste our time. Here are 8, 16, 8. Here, 15, 10, 10. Here, 12, 12, 8. Here we wrote down 9, 12, 6. Here, 16, 8, 8. 12, 9, 6. 8, 8, 4. 10, 10, 15. 8, 12, 12. 6, 12, 9. 12, 8, 12. 9, 9, 9. 6, 8, 6. 12, 6, 9. 8, 6, 6. 4, 4, 3, 8, 8, 16, 6, 9, 12, 4, 8, 8, 9, 6, 12, 6, 6, 8, 3, 4, 4, 8, 4, 8, 4, 3, 4, 0, 0, 0. About zeros, it's clear because if quantity of each is 4, the price will be 0. So profit of each firm will be also 0. Okay, so now our task is to find your Nash equilibrium on B. So Nash equilibrium in pure strategies. What is Nash equilibrium? It is the set of optimal strategies of each player such that no one wants to deviate. Yes? So we should find what each player will do in each situation, independence on what other players do. And then we will find such situations when no one wants to deviate. What means deviate? No one wants to change their strategy, to switch to other strategy. Here, strategies of our firms are how much to sell. So each player has 3 strategies, yes? So let's begin. In the lecture, you also did it. Let's speak about first player. What he will choose. For example, if the third player plays 2, we are in this matrix. And if second player plays 2, what our first player will choose? To play 2, 3, or 4? How do you think? What we should compare? We should compare profits, payouts of our first player. Yes? Once again, if third player plays 2, second plays 2, so what our first player should do? To play 2, 3, or 4. If
You
he will
should play
play
4.
Exactly, yes. If he will play 2, he will get 12 on the first place, yes? If he will play 3, he will get 15. If he will play 4, he will get 16. 16 is better than 15 and 12, so we choose to play 4 in this situation. Okay? Then, let's move on. If second player plays 3, what our first player will do? He compares 10, 12, and 12. 12 is better than 10, so we mark
3 or
12
4.
in each situation. Where, yes, 3 or 4. If second plays 4, 8, 9, 8. 9 is better, so mark it. Then, if third player plays 3 and second plays 2, this, yes, this line. So here, 10, 12, 12. On the first place, payoff of the first player is on the first place. 10, 12, 12. 12 is better, so mark it. Next, if second plays 3, this line. 8, 9, 8. Better 9. Here, 6, 6, 4. Better 6. Mark 6 everywhere. Then, here, if third player plays 4 and second plays 2, this line. 8, 9, 8. Better 9. Here, 6, 6, 4. Better 6. Here, 4, 3, 0. Better 4. So, now we wrote down, we marked how our first player will behave, will optimally behave behave in response to each action of other players. So, we can write down the best response. Now we know the best response of the first player. Yes? Let's move on and let's consider second player. The second player's payoffs are on the second place. Yes? So what our second player will do? If third plays 2 and first plays 2, what second will choose? To play 2, 3, or 4? What do you think?
4.
4, exactly, because we see 12 payoff on the second place, 12, 15, 16. 16 is bigger, so we mark 16. Next, if first plays 3, this line, this row, 10, 12, 12, better 12. Here, if first plays 4, 8, 9, 8, better 9. Move on. This row, 10, 12, 12, better 12. 8, 9, 8, better 9. 6, 6, 4, better 6. Mark 6 everywhere. Then next, if third plays 4 and first plays 2, first row in this matrix, 8, 9, 8, better 9. 6, 6, 4, better 6. 4, 3, 0, better 4. And next, now we should consider the third player. What the third player will choose? The third player will choose in which matrix he wants to play. So let's begin. If first player plays 2 and second player plays 2, where in this position? And the payoff of our third player is on the third place. So we compare 12 here, 15 here, the same place, 15 here, and 16 here. So 16 is better. So the third player will play 4 if first plays 2 and second plays 2. Let's continue. Next, please. Here, 10, here, 12, here, 12. Better 12. Next, 8, 9, 8. 9. Then 10, 12, 12. Better 12. Then 8, 9, 8. 9. 6, 6, 4. 6. Then 8, 9, 8. We choose second matrix. 9. 6, 6, 4. 6 bigger. 4, 3, 0. 4 is bigger. So, and now we should write down your Nash equilibrium. We have our Nash equilibrium if our players simultaneously and independently from each other choose their optimal actions, and they will they choose it together. Yes, and don't want to deviate. So we see such situations. How much? 1, 2, 3. Where we have three marks. 4, 5, 6, and 7. So let's write down all these pure Nash equilibrium. What to play? So definition of Nash equilibrium, it's the set of optimal strategies, not payoffs, but strategies. So, for example, first, what is optimal for each player to do? For the first player, it is optimal to play 3. For the second, it is optimal to choose 4 units to produce, and for the third, to choose 2 units to produce. So for the first 3 units, for the second 4 units, for the third 2 units. This is one of Nash equilibrium. First. Second. Here. 4, 3, 2. On the first place, here is the strategy of the first player, here the strategy of the second player, here the strategy of the third player. Third. Here, 2, 4, 3. Next, 3, 3, 3. Then, fifth. Here, 4, 2, 3.
Then 3, 2, 4.
2, 3. Mm-hmm. 2, 3, 4.
And 2, 3, 4. 3, 2, 4, yeah.
Mm-hmm. Yeah, this was 2. Great. So, if the task is to write down Nash equilibrium, you write down strategies, not payoffs. It's a mistake to write down in the answer 6, 9, 12. It's a mistake. We should write down optimal strategies. And these are only payoffs. If they will play these strategies simultaneously, they will get these payoffs. Okay. So, please, guys, questions. And we will move on. You can see that all these Nash equilibrium, in all these Nash equilibrium, we have total quantity that is produced, that is sold in the market. How much? 9. Yes. 4 plus 3 plus 2 is equal to 3 plus 3 plus 3. So it is optimal for the market to sell and to buy 9 units. Yes. And the price in each situation will be 3. Yes. So everywhere quantity is equal to 9 and the price is equal to 3. 12 minus 9. But it's just for you to notice it. And we move on and we'll speak about second problem. Let's see. In the second problem, we have in our matrix, we have first player's payoffs. Let's write down. We also have the game, but in this matrix, we have payoffs only for the first player. For the second player, we don't know his payoffs because it doesn't matter for us. And that's all. So the first player have how much strategies? 1, 2, 3, 4, 5, 6 strategies. And they are to play A, to play B, to play C, to play D, to play E, and to play F. These are actions of the first player. Actions of the second player. To play left or right. This is for the second player. So in this matrix, we have only first player's payoffs. We don't know the payoff of the second player, but we don't care. Here, the first player will get 3. The second, we don't know. We don't know. Here are 2. Here 1, 4. 5 minus 1, 6, 0. Minus 1, 4. 5, 1. So here are first player's payoff. And what we should consider. Our first task is to find set of player one's pure strategies which are not strictly dominated by some pure strategy. Let's write down the task. Set of player one pure strategies which are not strictly dominated by some pure strategy. So we should find pure strategies which are not strictly dominated by some pure strategy. What means to be strictly dominated? That means that in each situation, if our strategy is strictly dominated, it has payoffs less than in other strategy. Let's see. Please look at the payoffs of strategies of our first player, and please tell me which strategy will be strictly dominated by other strategy, by which strategy, and why. In each situation, its payoffs should be less, strictly less than payoffs of other strategy. Who can tell me? There is only one. Huh?
The D is the best one.
The D is compared with which strategy?
C.
With C, yes. So strategy C will be strictly dominated by D. Why? Let's check. Let's write down. C is strictly dominated by D. As the payoff in each situation is bigger than in C. Is bigger in D than in C. As if second player plays left, in D we will have 6 and in C we will have 5. That's 5 less than 6, and if second player will play right, in D we will have 0, in C we will have -1. -1 less than 0. So in each situation, payoffs are less than in D. So if we have such conditions, strict inequalities, we can say that C is strictly dominated by D. Okay. What you can tell me about weak dominance?
F.
Which strategy is weakly dominated by which strategy?
C is weakly dominated by
By
F. By F, because only in one case there is an
C is. Yeah. C is weakly dominated by F because you see, if left 5 is equal to 5, if right -1 less than 1. But we wrote down that C is strictly dominated, so it's not so interesting for us to write down about weak dominance of C, because strict is more how to say? Okay, no mind. What else? What
B
else?
and E. Yes.
Yeah. You see that E is weakly dominated by B. Let's write down. E is weakly dominated by B. Why? As -1 less than 1, but 4 is equal to 4. So that means weak dominance. But our task was to find out the set of pure strategies that are not strictly dominated. So what we will write down in the answer for this task. Answer. A is not strictly dominated. B, D, E, and F. Why we write down E? Because it is only weakly dominated, but not strictly dominated. So here would be A, B, each strategy instead of C. D, E, F. Guys, is it clear? What is the difference between strictly dominated and weakly dominated? And how we wrote down the answer for this task? Please ask questions, and we will move on. In B, we have almost the same task, but let's see the difference. We should write down set of player one's pure strategies. Please notice that in your task on Dropbox, there is a typo. You have here mixed strategies, but it's a typo. The right task is to find the set of players one pure strategies. Okay? Here, pure strategies, which are not strictly dominated. By some mixed strategy. So you see the difference here, pure, and here pure mixed strategy. So what means mixed strategy? I will give you an example. For example, mixed strategy to play B with probability 1/2 and to play C with probability 1/2. This is mixed strategy, the example. Yeah, to play B in 50% situations and to play C in also in 50% situation. And we can mix each strategy to play 2 or 3 strategies with some probability. Okay, we know it. So let's see how to solve it. What we actually know. We know that C is strictly dominated by D, and D is also mixed strategy. It is to play D with probability 1 and to play other strategies with probability 0. It's also mixed strategy. So we should eliminate C from this set. Next.
Извините, а у вас должно
also...
быть вместо pure mixed.
As I have said, here is the typo. In your task, there is a typo. And this is a right task.
Жаслан типа это опечатка.
Окей. Это просто... Окей, sorry.
Такое бывает.
let's move on. What we can say? We can see what our first player will do in each situation, independent on what our second player, his opponent, will do, like in the previous task. That's fine. So, if second player will play left, what our first player will do? Please answer. What he will play? If the second player plays left,
He
our
will
first player
play D.
will play D. Yes, because 6 is the biggest
Strictly
number.
dominating.
Yes, from his player. If our second player plays right, our first player
He should play
plays
like with probability of 1/2 B and E, I guess.
You can play B or E or mix. It doesn't matter.
Okay.
So B or E or their mix.
Yep.
Okay. So these strategies B, D, and E are optimal in some situation. So they cannot be strictly dominated by some mixed strategies because they are the best in some situations. So let's write down this conclusion. B, D, and E cannot be strictly dominated by as they are best responses to some pure action. As they are best responses to some pure action. So we cannot eliminate them. They are best in some situation. Okay? So C we do not consider because C is strictly dominated by D. So then, what else? We should check A and F. They are the last. Let's check A. If we will find some mixed strategy that will be better than A, so A will be strictly dominated by some mixed strategy. So let's mix some strategies. Guys, please choose for me 2 strategies that we will consider. Two strategies that we will mix. What do you think? What we should choose? To compare mixed strategy with A. How do you think?
Like C and F or D?
C is not good. Is not a good idea because C is strictly dominated.
So only
it will
C.
have
Only D.
And F also.
Only D. Then
We should consider 2 strategies and mix them to compare with A. So D and what else? For example, B and D. Why I do not consider D and E, or for example, because you know from here that E is weakly dominated by B. Yes, so B is almost better than E. So let's consider B and D and mix them. Let's write down. Consider a strategy when with probability beta we will play B, and with probability 1 minus beta we will play D. So here, with probability beta, we will play B. With probability 1 minus beta, we will play D. So if we play such mixed strategy, we will have also expected payoffs. Yes, we will, for example, if second player plays left, we will get 1 with probability beta and 6 with probability 1 minus beta. So we should write down expected payoffs from this mixed strategy. Okay, let's write down them. So it yields with probability beta, we will have 1, well, beta multiplied by 1, plus with probability 1 minus beta, we will have 6. This is expected payoff of our first player if the second plays left. And for such strategy, to strictly dominate strategy A, what we should write? That this payoff should be strictly bigger than payoff if we will play A, bigger than 3. This if second plays L. Then, next, for strict dominance, what we should also write down. If second player plays right, if we will play mix of B and D, we will have 4 with probability B beta and 0 with probability 1 minus beta. Well, multiplied by 4 plus 1 minus beta multiplied by 0. And this expected payoff from this mixed strategy should be bigger, strictly bigger than payoff if we will play 2. And this is the system. Okay, so let's solve. Beta plus 6 minus 6 beta greater than 3. 4 beta greater than 2. So here beta should be less than 3 divided by how much? By 5. And here beta should be bigger than 2 divided by 4. This is 1/2. Do we have solutions for such system?
Yep.
3 divided by 5, it is 0.6,
Uh-huh.
and 1/2 is 0.8. So we have set of solutions, yes?
Uh-huh.
So let's write down the conclusion. So mixed strategy, if beta belongs to from 0.5 to 0.6, then mixed strategy with B and D, then beta B plus 1 minus beta C. We can write down the mixed strategy like this. Strictly dominates A. And if we found at least one mixed strategy that strictly dominates our pure strategy, so strategy A is strictly dominated. And how many strategies we found? We found infinity number of strategies, yes, of mixed strategies, because we have interval. We can choose every beta from this interval. And with such beta, such mixed strategy will strictly dominate A. Okay?
Okay.
Our last strategy is F. We should check our last strategy. Let's check it.
Можно вопрос? А почему у нас там 1 минус b на c, ну на c?
Here, D. Thank you. Let's move on and consider the same strategy, the mix of B and D, and let's check if it can strictly dominate F. Once again. Consider a strategy beta B plus 1 minus beta D. It yields. We can write down in form of vectors.
I guess we did it right now. I guess we've done it already. I guess we've done it already.
No, we should compare this mixed strategy with not with A. With A we
okay,
check
okay,
with F.
okay.
It yields that expected payoff beta from B and D, beta multiplied by 1, 4 in terms of vector plus 1 minus beta 6, 0 should be bigger than payoff from F 5, 1. This is from F. This is payoff from mix of B and D. Okay, and let's write like this. So here will be beta plus 6 minus 6 beta should be greater than 5, and 4 beta should be greater than 1. What we see? We see that beta should be less than 1/5, and beta should be greater than 1/4. You see that there is no solution. We don't have interval of solutions. You see that beta should be at the same time less than 0.2 and bigger than 0.25. Yes, this is not. This is impossible. So we can conclude that F is not strictly dominated by some mixed strategy. Let's write down it. That means that F is not strictly dominated. We cannot find, for F, we cannot find some mixed strategy that will strictly dominate F. We cannot find. We tried, but we cannot. So let's write down the answer. For this point. Set of player one's pure strategies which are not strictly dominated by some mixed strategy. So this is what A is strictly dominated, B, yes, C also strictly dominated, then D, E, and F. D, E, and F. This is our answer. We write down F because it is not strictly dominated. We proved it. Okay? That's all. Guys, please ask questions.
Why we choose only B and D when we are considering mixed strategies?
We take once again. I didn't.
I
catch.
mean, like
Why we consider on
we're making a mixed strategy with strategies B and D. D is strictly dominating other strategies in left, and B is weakly dominating strategies in right. Why not E? Only because B is strictly or weakly dominating E, or what?
Yes. B weakly dominates E, so we cannot consider it.
Okay.
We can because E is weakly dominated. Yes, and AC is strictly.
Okay.
So we consider both B and D and mixed them. Okay, thank you for the question. Let's move on. Our next test. Our next task, we should write down player 1's best response as a function of players 2 mixed strategy. Write down player 1 best response as a function of player 2 mixed strategy. Is a function of player 2 mixed strategy. What we should do? We should consider what our first player will do in response to the mixed strategy of the second player. So let's, for example, say that mixed strategy of our second player is to play left with probability alpha and right with probability 1 minus alpha. Okay? Let's write down. Let alpha is it is exactly the probability of our second player to play L. And 1 minus alpha is equal to probability to play right for our second player. Then what we should do? We should write down players 1 best response. What means best response? What means best response? What to do in response to every strategy of our second player. So let's consider what we did. We checked payoffs, yes, in each station. So let's consider now payoffs of our first player if our second player plays such mixed strategy. Then expected payoff or expected utility or expected value, never mind, expected utility of the first player will be how much? If our first player will play A, he will get 3 with probability alpha and 2 with probability 1 minus alpha. So let's write down expected value, expected payoff. 3 with probability alpha plus 2 with probability 1 minus alpha. This if our first player will play A. If he will play B, 1 alpha plus 4 multiplied by 1 minus alpha. Next, if C 5 with alpha or minus 1 with probability 1 minus alpha. Minus 1. D 6 or 0. 6 with probability alpha plus 0, 1 minus alpha. E, expected payoff, minus 1 with probability alpha, 4 with probability 1 minus alpha. Minus 1 plus 4, 1 minus alpha. F, 5 alpha, 1 minus alpha. So let's rewrite them. Here, 3 minus 2 alpha plus 2. Here, 4 minus 3 alpha. 5, 6 alpha minus 1. Yes. Here's 6 alpha. Easy. Then 4 minus 5 alpha.
Minus 6 alpha.
Here. Where?
4 alpha plus 1.
4 alpha plus 1. Yes? So, what we should take, what strategy we will play, it depends on alpha, yes, on probability. Let's draw illustration, yes, because you see that these are linear functions, yes. Let's draw expected utilities. Let's draw illustration, and then let's see what strategies we should consider. We should consider such strategies that will give us maximal payoff. Yes, maximal expected payoff. And it depends exactly on the probability on this alpha. So, horizontal axis, here is alpha. As it is probability, it is only between 0 and 1. Yes? So here we will stop. And vertical line is expected utility on the first player. So let's draw all these lines. Alpha plus 2. As it is linear function, I can draw 2 dots and then draw a line. So if alpha is equal to 0, expected utility will be equal to 2. And if alpha is equal to 1, expected utility will be equal to 1 plus 2, 3. So we draw a line from 2 to 3. Please be very accurate. This is for A. Next, 4 minus 3 alpha is, if alpha is equal to 0, it is 1. No, if alpha is equal to 0, it is 4. If 1, it is 1. From 4 to 1. From 4 to 1. This for B. Next, C. Alpha is equal to 0, it is minus 1. If it is equal to 1, it is 5. Minus 1, from minus 1 to 5. minus 1 to 5. This is let's see. Then D from 0 to 6. From 0 to 6. Is for D. Next, E from 0, 4, from 4 to minus 1. From 4 to minus 1. E. And last F from 1 to 5. From 1 to 5. Please be very accurate. Something like this. This for F, this is C. So, we draw all expected utilities in each situation. So, what we should choose? As we want to maximize our payoff, we choose the maximal expected utility for each alpha. So, it will be upward envelope, yes? So, if alpha is small, we choose to play B. If it is in the middle, we choose to play F. And if it is very big, we choose D. So we should find these two dots. These alphas that will change our decision. Okay, is it clear right now what we should do?
Can you please repeat
We should compare.
after you draw this?
How do you find that, like, from which to which side we have to decide? I mean, from which to which part on alpha?
We should find
Yeah,
it
yeah.
right now,
Okay.
analytically.
Okay. Like
Yes.
to equalize two equilibriums.
So, yes, we equalize expected utilities of here of B and F, yes, and here of D, F. So let's write down more.
These are the interceptions of which one?
Of B, here F, here D. But it's only illustration.
Oh, okay.
And, we can say exactly that we should only compare B, D, and F. Only compare B, D, F, or B, F, D. So, when I will choose B, when expected utility from B is bigger than from F and at the same time from D. Let's write down it. From B, 4 minus 3 alpha greater or equal to from F, for alpha plus 1. And at the same time, 4 minus 3 alpha greater or equal to from D, 6 alpha. From here, we see that alpha should be less or equal to 3 divided by 7, and alpha less or equal than here 4 divided by 9. What is more strict? What is less? 3 divided by 7 multiplied by 9 here and multiplied by 7 here. So here 3 multiplied by 9, 27, and here 28. So this is binding condition for us. So alpha should be less or equal than 3 divided by 7. Then we will choose B if it is true. So this first alpha is equal to 3 divided by 7 here. Next, when we will choose F, when it is the most profitable for us, when it gives us the maximal payoff. When it is true, let's see, F for alpha plus 1 should be greater or equal to 4 minus 3 alpha, it's from B, and for alpha plus 1, greater or equal than 6 alpha at the same time. So from here, alpha should be greater or equal than 3 divided by 7, and alpha should be less or equal than how much? 1 divided by 2, 1/2. So if alpha is not so small and not so big, we will choose F. And you see that this here is 1/2. And next, last, D. Simple. From D, 6 alpha should be greater or equal than 4 minus 3 alpha, this from B, and 6 alpha greater or equal than 4 alpha plus 1, this for F. And you see that it's true when alpha greater or equal than 4 divided by 9 and alpha greater or equal than 1/2. You see that binding condition for us is what? Here multiplied by 2, here multiplied by 9, here 8, here 9. This is binding condition about 1/2. Alpha should be greater or equal than 1/2. So, great. So, let's write down the answer. We consider all our strategies, what to do. Now we can let's write down here, answer. So, our best response is a function of player 2 mixed strategy. So, for example, we have alpha from 0 to 1. Here, alpha from 0 to 1. And we have these binding conditions, 3 divided by 7 and 1/2. So, if alpha is between 0 and 3 divided by 7, we will play what? We will play exactly B. Yes? Here, B. If it is between 3 divided by 7 and 1/2, strictly between, we will play F. If it is between 1/2 and 1, strictly, we will play D. Then, what is next? If it is, if alpha is exactly 3 divided by 7, we are indifferent. You see, we are indifferent between playing B or F or mix of them, or some mix. So here, if alpha is equal to 3 divided by 7, we play mix of B and F. Mix B and F. If alpha is equal to 1/2, we are indifferent between F and D. Why? Because they give us the same expected utility. So here we can play F or D or mix them. Mix F and D. Our last moments are to check 0 and 1. Let's check. What we know about 1? If alpha is equal to 1, we will play what? We will play exactly D. You see this, yes? Because it will give us the maximal expected utility. So here D. But if alpha is equal to 0, what we can also play? If alpha is equal to 0, our maximal utility is given by B and E. You see? So here we will play B or E or their mix. So if alpha is equal to 0, mix B or B and E. This was our last step. So this is the end of this task. Wait. Please. I know that this topic was in the lecture, and you drawn these such graphs in the lecture, so I think that it should be clear. Please ask questions, and the third task we will not do today, but you can do it at home and check yourself, because now you know from our first two problems, now you know everything for solving the third task by yourself. Guys, please, if you have any questions, please ask. I will erase everything. If you don't have questions, so thank you. We will see each other the next week at the same time.
Okay, thank you.
Thank you.
Thank you.